In this video, we are going to talk about the IUPAC nomenclature of alkenes. An alkene is a hydrocarbon with a carbon-carbon double bond. Their general molecular formula is CnH2n. In this case, it will be C10H20. Please feel free to pause the video and cross check it if you'd like to do so. The carbon atoms where the double bond is present are sp2 hybridized, unlike alkanes where all carbon atoms are sp3 hybridized. The sp2 head-on overlap creates the sigma bond, and the sideways overlap of the p orbital creates the pi bond. This sideways overlap locks the molecule in a specific way, and therefore free rotation around the carbon-carbon double bond is not possible now. If carbon-carbon free rotation needs to be allowed, just like in the case of alkanes, then we have to break the pi bond. Consequently, because free rotation is no longer possible, the molecule can exhibit stereoisomerism, that is Cis-Trans isomerism or EZ isomers, depending upon which atoms or groups are present around the carbon-carbon double bond. It is better to use the EZ convention for IUPAC naming instead of calling them Cis-Trans isomers for uniformity, and also EZ convention is much more superior than Cis-Trans convention. Keep it also in mind that not all alkenes having a carbon-carbon double bond exhibits Cis-Trans isomerism. You need to have different groups or atoms attached around each carbon atom. Alright, let's do their naming. Naming alkenes is not very different from alkanes. The rules are quite similar. However, we need to consider few additional points. The first one is choose the long continuous carbon chain with the most number of substituents containing a functional group. In this case, we should include the carbon-carbon double bond. We have to treat carbon-carbon double bond as our functional group. And then carbon atom bonded to the functional group, that means the carbon-carbon double bond must get the lowest possible number. And our primary suffix now changes from ane to ene, alkane to alkene. And the last thing is, if the molecule exhibits Cis-Trans isomerism, then it is better to use the EZ convention. Let's look at some examples. We have an alkane and we have an alkene. We are going to do the naming for both of them. If you take this as your long continuous carbon chain, then you will have two substituents, but in that case you are going to have only 7 carbon atoms in the parent chain. On the contrary, if you take this one as your long continuous carbon chain, in that case you are going to have 8 atoms. 1, 2, 3, 4, 5, 6, 7, 8. On the other hand, if you do the numbering starting from here, 1, 2, 3, 4, 5, 6, 7, 8. Now the substituents are at 2 and 6 position, and therefore this is preferred because we always have to give lowest locants for the substituents. So therefore the IUPAC name for the alkane in this case is 2,6 dimethyl octane. Now come to the right hand side. We have an alkene. Can we still choose the 8 carbons as our long continuous carbon chain? No. Now we have to choose this one as our long continuous carbon chain, so that it is inclusive of the carbon-carbon double bond. Now let us do the numbering 1, 2, 3, 4, 5, 6, 7. Our substituents are at 2 and 6 position. We should not do the numbering on the other way around, I mean right to left, because if we do that, then you will be giving higher number for the alkene. That we should not do. Alkenes should always get the lowest number possible. So our carbon-carbon chain should include the alkene. Not only that, we have to give lowest locant for the alkene compared to substituents. The IUPAC name for this molecule is 2-ethyl. We have a ethyl substituent, we have an ethyl group, we have a methyl group. So 2-ethyl, 6-methyl, hept, just one word, and then 1-ene, not 2-ene. The alkene starts at 1. That's what we should mention. Hept 1-ene. That's the correct IUPAC name for this molecule. Let us look at more examples. In the first case, if we do the numbering left to right, then it is 1, 2, 3, 4, 5, 6. We have a 6 carbon chain. So hexene, between 3 and 4 we have the double bond. Even if we do the numbering on the other way around, it is still going to be 3 to 4, and therefore this numbering scheme is fine. So can we just simply name it as hex 3-ene? No, that's not the way we should name this molecule, because stereoisomerism is possible in this molecule. The hydrogen atoms are hidden there. We just have to use the same Corning-Ingold pre-log rules that we used during the RS configuration. The same thing you have to do it around the carbon-carbon double bond. There you will be doing around the chiral center. Here you are going to apply the same rules around the carbon-carbon double bond. The atomic number of carbon is 6, and therefore that gets the top priority. So 1, hydrogen gets the least priority, atomic number is 1. So here least priority, on this side top priorities. So your top priorities are on the opposite side. That means this is an E isomer, and therefore the correct IUPAC name for this molecule is hex, because 6 carbon atoms are there in the parent chain. In parenthesis 3-ene. That's the correct IUPAC name for this molecule. Let's go to the next one. Let's do the numbering once again. 1, 2, 3, 4, 5, 6, 7. The pi bond is between carbon atoms 2 and 3, and the substituents are at 2 and 6 position. We should not do the numbering on the other way around, because if you do the numbering on the other way around, then the pi bond will appear 1, 2, 3, 4 between 5 and 6. That we should not do. Even though the substituents will still be at 2 and 6, you will be giving higher number for the alkene. That we should not do. Therefore, this numbering scheme that we have done is correct, left to right. So the correct IUPAC name for this molecule is 6-bromo. We still have to follow the alphabetical order. 2-chloro, 7 carbon atoms are there, so hept. Now we have to see whether stereoisomerism is there or not. Stereoisomerism is there because we have chlorine and carbon on one side, and then hydrogen and carbon on the other side, and therefore stereoisomerism is possible. So chlorine's atomic number is 17, so that gets the top priority here. Carbon gets the least priority. On this side you have hydrogen, that gets the least priority. You have carbon atom attached to it, that gets the top priority. So your priorities are on the higher priorities are on the same side of the double bond, and therefore this is a Z isomer. Therefore The correct IUPAC name is 6-bromo-2-chloro-hep in parenthesis 2Z ene. That is the correct IUPAC name for this molecule. Let us look at more examples. We have a cyclohexene now. So, how to do the numbering? That is the most important thing here. So, if you start from here 1, 2, 3, 4, 5, 6, then your pi bond is between C1 and C2, but your substituents are at 3, 6, 6. On the contrary, if you do the numbering starting from here 1, 2, 3, 4, 5, 6, in that case your pi bond is still between C1 and C2, but now your substituents are at 3, 3, 6, and obviously this is preferred, and therefore the correct IUPAC name for this molecule is 6-bromo 3,3 dimethyl cyclohexene. No need to mention the chain locator position here because it is a cyclohexene. You can mention it as cyclohex-1-ene, but that is not mandatory. So, this is the correct IUPAC name for this molecule. Alright, let us discuss one more tricky example. In this case, if you select this as your long continuous carbon chain and number it 1, 2, 3, 4, 5, 6, 7, the pi bond is between 3 and 4, and the substituents are at 2 position tertiary butyl substituent, and then 5 position 1 methyl group. But if you select this as your long continuous carbon chain, then it is 1, 2, 3, 4, 5, 6, 7, 8. In that case, your pi bond appears between 4 and 5, and now you are having 4 substituents, 2, 2 methyl group, at 3 position another methyl group, and then at 6 position another methyl group. That is the one you should choose. Even though this gives higher number for the alkene, this is the chain that has the most number of substituents. So, it is a long continuous carbon chain with the most number of substituents. So, therefore, that is the one you should choose, and therefore, the correct IUPAC name for this molecule is 2,2, 3,6 tetramethyl act, and then we have to consider the stereoisomerism that is possible. 4, the hydrogen atoms are on the opposite side. So, this is a clear case of E. So, 4E ene. That is the correct IUPAC name for this molecule. How to do the naming for this molecule? Here, this definitely has to be part of the parent chain, and then how we are going around it. So, if you go down, if you select this as your parent chain, then you will have 1, 2, 3, 4, 5, 6, 7, 8 atoms, but you will have a complex substituent. On the contrary, if you select this as your parent chain, then you are having 2 substituents. Remember, the most substituted long continuous carbon chain is what you should choose, that has a carbon-carbon double bond, and therefore, this is the correct parent chain, even though it is going to have only 7 carbon atoms. In the other case, we would be having 8 carbon atoms, but still we should not select that because then you are having one substituent. But now with 7 carbon atoms, you are having 2 substituents. So 1, 2, 3, 4, 5, 6, 7. So at 5 position, you have a methyl group. At 4 position, you have a butyl group, and therefore the IUPAC name for this molecule is 4-butyl 5-methyl hep, and then we have to look for the stereoisomers. So here you have a hydrogen atom that is hidden, here you have a hydrogen atom that is hidden. So in terms of priorities, this gets the top priority, this gets the second priority, this gets the second priority, this gets the top priority. So your priorities are on the opposite side, higher priorities are on the opposite side. That means this is an E isomer. So hept 2E ene. That's the correct IUPAC name for this molecule. Alright, let us look at one example where we have an alkadiene. By the way, when 2 double bonds are there in a molecule, we don't call it as alkadiene, we call it as alkadiene for better phonetics. So in this case, you have to choose this as your continuous carbon chain. It should include both the double bonds. You should not choose anything else. So 1, 2, 3, 4, 5. That's our parent chain. At one position, stereoisomerism is not possible because both of them are hydrogens, but at 3 position, stereoisomerism is possible. So how to do the naming? At 2 position, we have the butyl chain, and therefore the IUPAC name for this molecule is 2-butyl penta, the A is back, and then in parenthesis 1, and then 3E. Why 3E? Because you have a hydrogen here, you have a hydrogen there. So this gets the least priority, hydrogen gets the least priority, whereas the carbon gets the most priority as per the CIP rules. So your higher priorities are on the opposite side, and therefore this is a clear case of E isomer. So 1,3E diene. That's the correct IUPAC name for this molecule. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media. Thank you.